We're going to look at another compounding formula, but before we do, I want to point something out. No matter how much money you have in there, if you were to compound something more frequently, you're going to be left with more money. So if we had $1 invested at 100%, which would mean our multiplier would be 2, for 1 year, this is the following A values, our actual money that we would get after compounding for annually, quarterly, monthly, weekly, and daily. So if you notice, the more frequently we compound something, the more money we have, because compounding is a positive, even if it is just a difference in some cents. So what if we have something that never stops compounding? This is called continuously compound. And when we continuously compound something, we are given a new formula. I call this the Pert Formula because it's our A value, which is still our actual, equal to our P, which is still our principal, times E. E is a constant, a mathematical constant. So just like pi is represented of 3.14 and so on, E is represented by the constant value 2.71 and so on. So E is always a constant number. We don't plug anything in for it. It is a number. Then we have R and T. R is still our rate. T is still our time. All that you have to remember is that it's P times E to the RT because your rate and time are going to be in the exponent. So let's look at this example. If we had 10 bacteria cells that doubled every 20 minutes, I'm sorry, I want to make that every hour. So we have 10 bacteria cells that double every hour. What's our constant or rate of growth? Well, since it says the word doubles, that means our R value is going to be 2, which would make it 200%, which is doubling our initial value, P. So if it continues to grow at this rate, how much bacteria will be present in 4 hours? So we're going to solve for A. A equals P, which is our 10 cells, times E to the R, which we said was 2, times T, which is 4. Okay, so this is going to be a very large number. When I plug this into my calculator, I'm going to do 10 times, and I'm going to do 10 times E. Now, I don't want you to use the alpha button. The button you're going to use is second, and then the ln. Right above that ln, you should see e to the x. So by hitting second, we're going to choose e to the x. So you're going to get your e, you're going to see the base of e, and then you're going to see how the cursor is up in the exponent. Please, again, do not use the alpha button for the letter e. So 10 times e to the 2 times 4, which is to the 8th. So my value, my A value, is going to be 29,809 cells. All right, so let's look at an example with money. Let's first compare compounding quarterly and compounding continuously. So if your account compounds quarterly at a 6.75% rate, how much will you have if you invested $8,000 for 15 years? So this means my P value, my initial value is 8,000 times 1 plus, my R is going to be 0.0675 over N, since it's quarterly, N is 4. And then my exponent is going to be 4 again, times 15 for 15 years. Okay, so be careful when you plug this in your calculator. You're probably going to have to put in 2 extra sets, or an extra set of parentheses. And when I do this, I get 21,834 and 55 cents. All right, so now let's compare this to if we were to compound this continuously. So I'm going to have my formula, P times E to the R T. All right, so P, my principal, is $8,000 times E to the 0.0675 times my time, which is 15. And when I plug this into the calculator, again, remember to use your second ln button for the E raised to that exponent. I get $22,019.79. So like we said, the more you compound something, the more money you will have. And we clearly have more money if we were to compound this continuously. Alright, so how do you tell which compounding formula to use? You are going to stick with our original compounding formula unless it says the words compounding continuously. If it doesn't say the word continuously, then you're using that original. And if it says continuously, you're going to use the Pert formula. So, just in summary, if we took $10,000 at a 2.75 interest rate, and it was compounded quarterly, I did the math for you, and in 15 years, you're going to have $15,084.59. If you did it continuously, you would have $15,105.90. So it's asking how much more? Well, if I subtract my compounding continuously from my compounding quarterly, I'm going to have $21.31 more. May not seem like a lot to you, but it can make a big difference over time.